so the value that I've seen for BIM is to make better decisions and to make them faster. And as I thought about the main mechanism with which BIM allows to do that is really through visualization, integrating information and automation. So I want to motivate that focus, and then I want to share examples from various projects in various parts of the world, some quite new, some a little bit longer ago, also to show you that companies around the world have been working in this way with BIM for quite some time. So as some of you know, I've been proponent of BIM as a really good method, I think best method we have for managing the information on projects for a long time. I built my first BIM in 1988 and have been working with many companies around the world to bring BIM-based methods to practice. And that has also led me to develop VDC and write this book, Integrating Project Delivery, that really shows how you apply VDC so you can integrate the projects and create high-performing buildings. But okay, let's jump in. So what problem we are really trying to address? I think a problem I've seen around the world is all sort of topics, questions like these. So have you experienced these challenges on your project? The client changes his or her mind, or somebody shows up with a better solution, but late. Or detail gets added, the solution that you thought was good initially in the project, early in the project, becomes less good. Or new project stakeholder shows up and all of a sudden has new ideas about the project. Or cost or other feedback arrives late, and now you have to change, and so on. I think most people working on projects have experienced at least one, if not all of these challenges. But the result of that is, or that the fact is then, the right decisions were not really made. I know even if you tried, I'm sure you were convinced that they were the right decisions, but in the end, the right decisions were not made, and you don't have certainty of product or certainty of product information about the building. And most likely, you will either have to do rework or deliver a suboptimal design and project, or both, which of course is not great. And so I've had the privilege of being able to work with quite many companies to try to address these challenges, which are of course very real, and see how can BIM help us address these challenges. Because this is not the problem of the architect or structural engineer or builder or owner or any particular party. Of course, everybody has a role. So we really need to find a method that works for all of these parties to address these kind of problems. And of course, that's also, as you know, I'm sure from your uses of BIM, that's where BIM is really powerful in terms of enabling the collaboration between different parties. So why did I come to the conclusion that visualization and then integrated information and automation are really the powerful mechanisms? One is visualization is, it leverages everyone's experience and expertise. You've heard the phrase, I'm sure, seeing is believing. A picture is worth 1,000 words. Basically, for many aspects, many decisions in our industry, we need to count on the expertise of experienced people. Because we don't have yet computational models for everything, we cannot yet simulate everything. So the experience from various projects is very helpful in making good decisions quickly. But for that, I found we need to make sure that everybody is really thinking about the project in the same way, understands the options in the same way. And that's where I've seen really visualizations in 3D and 4D of other information being very powerful. Actually, I would go as far as there should not be any discussion on any project without the visualization of what we are discussing. I've seen the discussions and the decisions to much more productive when it is about something than when we're just talking at each other. Then, but then we also, so in addition to, of course, enable the social interactions on projects, we have many management and engineering systems that require information. And that's where I found integrated information, like using the I in BIM, becomes very powerful because we can then make sure, for example, that the architect's information matches the information of structural engineers, detailers, subcontractors, etc., among many, many other parties. This is a major problem I've seen on many projects I've been part of. The need to keep different information bases updated as something changes. Almost impossible, and leading again to a lot of delays and rework and other problems. And so if we have a strategy for integrating information, we can avoid these kinds of challenges. We can come close to something like, single source of truth, which you might have heard, or an actual digital twin that's not just visual, but also has the information. Some statements are, in God we trust, all others must bring data, or data is the new bacon, something that I've heard quite a few times in many companies. The other mechanism how I see BIM helping is because BIM can really enable automation, automated calculations, simulations, so that we can shorten the feedback cycles on ideas. I think this is really, really critical to have a good velocity of decisions and feedback. And so if it takes several weeks to get cost feedback or CO2 performance feedback or schedule feedback or whatever feedback you need to compare a couple design options to make sure that you have a design that you can proceed with, that's not very productive. That's not helpful in my experience on projects. And my attitude has always been, why do something manually that a computer can do? We have plenty of things to do. And so whatever we can give to the computer, please, let the computer do it. And we certainly have to predict the performance for many criteria and many design options. And a statement that has really resonated with me that I've heard many years ago is from a computer scientist from Georgia Tech, Alain Perley. He says the automation of process changes everything. You will see several examples in the end, and one example at the end, I think, will illustrate this point very much. Okay, so a couple more statements just to remind us of the importance of BIM, because I think BIM helps with all of those. I realize these statements are extremely obvious, but I don't find that they're actually followed on that many projects, right? It's totally obvious that we cannot do anything without information. And you cannot do anything well without good information. And I would say good information in our context means every project needs many disciplines that work over many phases, is integrated information. If the information is not integrated, connected, it's almost impossible in my experience for the information to be good. And then how can we do things well if we don't have good information? I know we do that, but I think that should be much more, I think has much more importance than we see really in practice. And building on that, I really like a comment that one of my PhD students quite a few years back made to a superintendent on a construction project, where she got frustrated that this superintendent didn't want to bring some innovation to the project. And finally, she said, okay, George, is the information working for you, or are you working for the information? Because my experience has been that often when I was an engineer, I had to work for the information because I needed information to do something, as we just saw and as we know. And that was often much more effort than I expected or had time for. And so I had less time for the actual engineering and the actual planning and management aspects than I really should have had. And so my work, I would say, was not quite as good as it could have been if I had information ready working for me. And it wasn't just me when I was a young engineer, but it was really, I saw everybody in my office and in other companies suffering from the same challenge. So I think this is something I invite you to reflect. To what extent are you working for the information, and to what extent is the information working for you? And finally, we hear the word optimization a lot, and of course we have to optimize what we do for economic reasons, for the planet, for many reasons. But you can really only optimize the things for which you have data. And I think you'll also see that later in the presentation. So these are, I know, very obvious statements, but they remind us, I think, of the absolutely critical importance of having good information so that we can create really high-performing projects. So I want to now go into examples of visualization, integrated information, and automation, so you have an idea of what I'm actually talking about. I mean, these are just a few examples. There can be many, many more. You probably have quite many once you see them and understand what I mean with these words. So and hopefully that triggers you to think about how you're going to support the decisions you have to make on a project with which information BIM strategy. Because yeah, you have to make decisions, so you need to have a strategy for how you best support the making of those decisions. Let's see, I need to click off some window. Yeah, so it's important to think about what is it that we can decide to do, and then what do we want to measure so we can see it's successful. In this context, right, you have to absolutely decide what information you actually need to represent. You have to decide how you're going to use information. These are all decisions you can make and therefore need to make. You know, what you're going to visualize, show, what you're going to integrate, what you're going to automate. Of course, what kind of BIM you're going to use in terms of level of development or model maturity. Depends where in the world you are and what term you like. How is it structured, content, format, and all that. And of course, tools eventually. So these are all decisions you have to make so that you end up with the right method that you think is correct for supporting decisions you have to make. And then how would you know that, you know, the effort you put into all this is worth it? Here's a few examples of things you could measure pretty soon after you have made the decisions, after you have supported the decision. You can measure how many are actually using the generation and the use methods that you have defined. You can measure how quickly decisions are made and how much they stick. Many organizations that I know have started to do that, and they have seen great value from understanding this performance on their projects. You can see how easily conflicts are found and resolved, and how quickly they are resolved, and whether they appear again or not. You can see how quickly project participants and stakeholders understand design options, how much rework there is due to missing, poor, or late information, how your information management strategy and decision-making strategy is enabling downstream work. For example, to what extent can you do offsite fabrication from BIM? And there's more, but these are some of the main ways I've seen companies in industry assess whether their information management strategy, which is what they decided here, decision support strategy, is actually working. And then, of course, to make corrections if the performance is not where they would like it to be. All right, so I want to jump into examples now. I have organized here, you will see two guides to these examples. I will go through these guides quickly because I will show these examples. But I have three examples related to the buildability of the building. So I'm using the criteria that we have defined in the Integrating Project Delivery book that you saw on the title page, the buildability, usability, operability, and sustainability to organize the examples. So I wanted to have examples for each of those four major performance areas of buildings. So is the building attractive for users? We have some examples there. Is the building, can it be operated efficiently? And is the building sustainable? So let's jump into these examples. I think visualizations, I imagine, is quite clear, obvious to you and straightforward. This, of course, includes 3D and 4D visualizations, but also then related information to those. And what I found is that when you have an important question or problem on the project, you can, even if you don't have a visualization, if you don't have a way to actually immediately create that visualization to support a decision about that, you can, with the tools today, create such visualizations and pay for that out of project budget and get your money back. At least that's what my main experience is. Excuse me, just take a sip of water here. So on the right, for illustration purposes, you see in the upper picture a judge doing a conceptual design review in virtual reality cave, which was done quite many years ago, actually. And it was the first time, at least this client, which was the Justice Department of the United States, had employed this method for conceptual design review instead of building actually a physical mock-up, and which was much more expensive and much more cumbersome, and led to much less good feedback than what we were able to do here in a 2-hour session with the judge and his team. And below you see what we see really done on many, many projects, on almost all projects these days, is the coordination of the main technical systems in a building with 3D. That's partly integrated information because you can, and partly automation, because obviously you can automate some of the checks, but it's also visualization. That's why I put it here, because not everything about the performance of our system should be has been codified yet. So we need also, in my experience, people with experience to actually review a design visually, then say, yes, this works or doesn't work. A nice example of supporting decisions, like here in this case, can the wastewater treatment plant be operated? We saw a few years ago in the design and construction of the largest wastewater treatment plant in San Francisco. This was actually during the pandemic, and we were able to support the project team from my research group, my student Simge, with virtual reality applications, because everybody was in home office during the pandemic, and still they had to move the project forward. So they sent VR headsets to everybody's home office, and then they had these project review meetings here with the maintenance staff to figure out, does the access work? Can they, is it productive for them to operate and maintain the facility? Imagine you might have done, if you're working especially in the industrial sector, mining sector, you might have done similar reviews as well. Or then simply having a design review meeting, update meeting to say, well, how is everybody doing with the design? Is everybody good with where we are today? Does everything work? All the systems, the design, the performance for which you're responsible with, is that okay for the project? And it was very powerful, again, to sort of be in the same space with the others. Here you see the avatars of the various parties floating around, so you can see what everybody's looking at, and discussing this design in an integrated way, right? Or last example here quickly, this has been interesting for me to see at Disney, when they design theme parks, they really, it's normally not just one person, but for confidentiality reasons, it's just showing it like that. But they typically have design sessions. I mean, when they're in the middle of a project, what I saw is that they had design sessions twice a week with about a dozen people co-designing part of a theme park, being immersed in the environment that the people they're designing the theme park for, the guests, the children, the families that are going to go there, how they will experience the theme park, designing it directly in that visual environment. That was is an extremely powerful tool, because that's really an example of what I mentioned at the beginning. We cannot yet, mathematically codify everything. So this experience from the range of people, architects, ride engineers, and many, many other parties that have to come together in this case, and then make a good design, finding a way of harnessing all of their expertise concurrently is really, to my knowledge, the most productive way in which we can advance these projects. So I want to also show how, for one of the examples, I will also show what some of you that might have taken BDC become familiar with or are familiar with, how the decisions, like in this case, to use a virtual reality environment twice per week connects with ultimately what the client needs to achieve. In this case, the client, right, really cares about the guest experience, and they measure this very carefully in the case of Disney. And they had, of course, a target there. So in terms of then what the project team can achieve during the project is to make sure that they build the maximum number of things that the guests, the visitors to the theme park might care about for the budget they have. They don't want to be over budget and they don't want to be under budget. They have the budget and they want to use it for the maximum benefit possible. So that's where the strategy to design in virtual reality came from, right? So they had 2 integrated concurrent engineering sessions, ICE sessions, per week with about 15 most critical designers, and they wanted to make sure that these sessions really happen. So that was the target. And then in each session, they wanted to look at a good number of design options because they felt like by looking at as many design options as possible, we have the best chance of finding the right set of attractions for the budget we have. So I think it's important to connect the specific decisions you're going to make on a project, like are we going to build this attraction or that attraction, or how exactly are we going to build it or design it, to the choices you make in terms of how you're using BIM and related technologies, to the results you want to have at the end of a project, and then the results you want to hopefully get when the building, or in this case, the theme park, is being used. And so I encourage you to always create that story, because it also helps align everybody on the project behind why you're doing BIM and what you really want to achieve. And you can learn much more and get feedback on whether that was productive or not. So as I said, I think visualization is quite obvious, and as you saw, I focused a bit on mostly 3D visualization, but as I mentioned, you can also illustrate the timeline or other related information, right? So you should think of visualization quite broadly. Then, but yeah, of course, we always need to support these kind of social interactions on projects, and absolutely key for making decisions and for building trust. But then we also have engineering systems, structural analysis system, energy systems, management systems during operation, during construction, scheduling, and so on, cost estimating. So we need to do a lot of analysis to figure out how we're doing and whether our course of action is good. And so in support of that, integrated information is super, super important and helpful. Actually, on the right, you see an example of one tower of 2 towers that was developed in downtown Chicago by this small company, Optima, a family business, who was able to beat all of the big developers in the United States to win the rights to develop this last piece of open land in downtown Chicago with a 60 and a 42-story tower, which I think was quite remarkable and amazing for a small family business. And they were able to do that because of integrated information. Because before they put a bid in for the property, they developed 13 different scenarios from architectural, structural, facade, mechanical, energy, performance, or design perspectives. And then also looked at the schedule and cost implications of these 13 different options. So they had a really good understanding, which they could do very quickly thanks to integrated information. And so they had a much deeper understanding, much better understanding of the potential of that property and how they could develop it with the minimum risk, that they were able to offer a much more competitive bid and won the right to develop it. So I think that really is an example of the power of integrated information. Integrated information, though, can be a little more challenging because we have to teach this stupid tool, the computer, to do something that, for us is often obvious. So that can be challenging. But I showed you, a 42 and 60-story tower. I showed you the Disney theme park. And you can say, yeah, that's all good for these kind of big projects. Does this actually work for a small project? And this was a really interesting experience I had actually by Carolina Lozano, a student that was in our master's program from Peru. And her family has a small construction business here in Lima. And as she was learning about BIM in our classes, she came to me and said, well, I'm curious, yeah, Martin, you keep showing these big projects, but I'm curious whether this would actually also work for small projects that we do, like, small development of a small retail area, as you drive through the city in lots of places. And she said, I have access to really all the data from the company because it's our family business. So do you think it would be okay, interesting to do a comparison between how we work today with 2D drawings, and then we could integrate the information, cost estimating, quantity takeoff, and BIM. What would the cost of doing that be, and what would be the benefit? So she found that on this particular project, they needed at the time 48 man-hours to make the cost estimate. And so then she built a BIM and used that for the quantity takeoff and to make the cost estimates. And you can see that the BIM-based effort was actually longer, was 53 hours instead of 41. But then as she reflected, she said, well, actually 32 of those 53 hours are things I had to do to set things up that I wouldn't have to do on the second project. If I did do a second project, I would only have to do the project-specific work, which was 21 hours. So that would be half of the time. So as you can see that with about 2 projects, you're break even. And after that, you are much faster with the BIM-based method, even with these types of small projects. And in addition, she found benefits worth about 10% to the company. With the BIM method, she saw a way to avoid almost 4% of mistakes that were made with the other method, with the traditional method. And she saw change orders worth about 6% that they also could have realized more easily if they had seen them earlier. So this was a really quite interesting experience to see that, yes, even in small projects, businesses, even more than 10 years ago, it made sense to work with integrated information, in this particular case, do cost estimating. Another example one of the first examples where I really saw the power of integrated information was the development of this quite high-end luxury apartment complex in Scottsdale, Arizona, also by this company Optima that I mentioned for the Chicago Towers. This was really quite a remarkable project. It was done before the financial crisis. So again, as I said, I want to show some examples that are more recent and some a little bit further back to show you that these companies have been working with these methods for quite some time. And this was a remarkable project because it has 700 apartments and not 2 apartments are alike. Every apartment has a unique feature that only that apartment has, which I think is quite amazing. The other remarkable thing is that they have double the landscaping across the whole project than the ground area of the site, which in the hot climate of Phoenix, Scottsdale is, of course, super nice. It actually lowers the temperature in the area in the complex by about 6 degrees Celsius compared to the outside. And so they integrated lots of information to figure out buildability, usability, and operability. I'll just flip through. I'm sure you're probably quite familiar with this, especially since this was done a few years back. But detailing, construction planning, coordination of systems, getting data for various analysis, and that's one example I want to go a little bit deeper because it's super hot. Obviously, as you probably know, in Arizona. So that's why they wanted the plants. But then, of course, it can be very expensive to maintain the plants and keep them growing. So they organized the project into different zones according to how much shade there was and how much sunlight there was. They had sort of 4 zones, and then they tested in parallel as the project was being designed, what plants did how well in which zone with how much water, so that they could find the plants that did the best with a particular amount of shading with the least amount of water. And of course, this kept changing as the design kept changing. So they had integrated information in BIM so they could rapidly calculate, given the new configuration of terraces and apartments, etc., where they needed how many of which plants and how much water they would likely need during the operation to support the growth of those plants and make the project the complex look good. I thought this was a very nice way of using integrated information and support really a fundamental feature, a key feature of the design, and also improve the sustainability of the complex by having more plants, having lower temperature, which lowers the HVAC cost, but also not having to spend or spending the minimum amount of water you could get away with. So this developer actually credits working with BIM and making better decisions with BIM for still being in business, because this was obviously quite a high-end complex for which the market in 2007, early part of 2008 was very good. And because of BIM, they were faster and were able to sell enough apartments, which was the client objective here, that they could sell as many apartments as quickly as possible. And to sell those apartments as quickly as possible, they of course needed to build a sufficient number of apartments. So that meant they had to really manage the risks as quickly as best as possible. And so there, as you could see, for example, here, the risk and challenge, the one that illustrated was to make sure you have the right plants so that you can operate then the facility easily and the place looks as attractive as possible so that people want to buy these apartments. And so again, this is how decisions to use BIM and integrated information allowed the collaboration and decision making by the many professionals. They looked at many more aspects, as you can see here in the numbers. But to be a little bit quick, I just want to give a summary here. And again, encouraging you to think through the whole story, from decisions you make in terms of how you're going to use BIM to the effect you should be able to measure quickly, to the effect that should have on the project, and then the future use of whatever you're designing and building. So finally, last example on automation. I think that's the future. I think we have to start to automate more. And if you're already automating quite a few things of your work, then fantastic. If not, I really encourage you to begin to automate. Of course, there's automation of creating details, for example, automation of fabricating from the BIM. In many parts of the world, this is now quite well established. Here, I want to show an example of automating for optimization. Automation is typically most expensive of the three methods. So you need to, I think quite carefully, strategically, about where you need an automated method. In this particular case, one of my PhD students, Filippo, came to me a few years back and said, "Hey, Martin, I think we can fully automate the structural design of a steel structure, actually a composite structure like we have in California, which is a steel structure with then a metal deck and then a little bit of rebar and a little bit of concrete, which is the typical structure for buildings. We worked on buildings much bigger than the one showing there, but we had to sign a non-disclosure agreement, so we can't actually show the actual building." And I said, "So what do you mean by optimize?" He says, "Well, what I mean by optimize is not just optimize for material weight or material cost, as you can do already today. What I mean is that we actually optimize for all the cost, that we optimize for material cost, fabrication cost, and erection cost," which has been really elusive up to that point. So in the context of, so we had to work actually pretty hard to bring together property developer, architect, structural engineer, general contractor, steel fabricator, steel erector, because we needed data from all of them. So they needed to trust each other and us that we, would keep the data confidential because we wanted to work with real data. So in the context of one project, we were able to develop this optimization method, or Filippo, I should say, was able to develop this optimization method. And then we were able to apply it to a new project. And I want to quickly show the results that we got from this, automating the design of the structural system, and so that we can be optimized. That's right, because if it's automated, then we can run through many different options. And anyway, let me show the results. So the structural engineer did the design, how they normally do it. It's a very good structural engineer. And they created a design over several weeks that cost about $4 million. And he optimized the automated method, developed the structural engineering in 1 hour, and came up with a structure that performed at least as well structurally, of course, but cost almost 10% less. You can see that all of the savings are coming from details. And this was really interesting for me to see that basically because we are designing the main structure and then the details concurrently, we can go back and forth between different designs and see what design of the main structural elements leads to the most productive details. And this is something that could happen on a project. You might just be lucky if you do it in a typical sequential way. You might just be lucky that the structural engineer happens to choose the particular details that work for the particular fabricator and erector, or might be somewhat unlucky. I mean, I wouldn't say that was really that bad here. It could be much worse, of course, but still, the developer, you can imagine, was quite happy to have 10% less cost on the structure and put that in a part of a project where the customers, the future users, tenants, purchasers of the condominiums, it was actually a mixed use project, could actually see it or experience it. So yeah, you can see that the savings here comes from lots of detail and all the details. And the ability to better align the detail with the main structure is something that the automation enabled. And then we could see that this actually leads to cost reduction. And we cannot generalize that all the time we will save 10%, but I think it's, my experience, probably not an unreasonable number, actually. So here, right, again, if you connect the story to what the developer wants to do, developer wants to wanted to lease this building as quickly as possible, and so wanted to make the building as attractive as possible. So building as many amenities for the renters as possible, more than the competition can offer, was part of the strategy. So that's where then the optimization of the structure through the automated design software became an important part of it, of enabling that strategy, as you saw from the cost savings. So the second guide to the examples I have is through visualization, integrated information, and automation. So I'm happy to share the slides if that's something the organizers of the president of the conference would like. And so I wanted to also give you a recap here. Right, we saw some examples of visualization, integrated information, and one example of automation, with a couple others I briefly touched on. And so hopefully this is a guide that, if you ever look at the slides again, helps you think, maybe get some inspiration of what you might want to do in terms of visualization, integrated information, and automation, so that you support decisions. So yeah, I think you've seen that we call it VIA, visualization, information integration, and automation, enables faster and better decisions, and provides through that certainty of product information, and basically makes also the project unfold much better. So to summarize, right, I encourage you to think about how you're going to leverage visualization, integrated information, automation on your projects. Which decisions are you going to support with which of these strategies? You really should decide, and you should have a strategy, and you should have a strategy for how to probably move towards more automation going forward. So for example, what decisions are you going to support with visualization? Here, an illustration from a shopping center in Germany, where they wanted to, make sure that the detailing of the structure supported the overall architectural vision of the project. Or another project, actually the same project in Germany, where they did, was the first project where this company did quality control with iPads. So they integrated specification information, BIM, and inspections. And we're able to not just get a list of mistakes, but actually also able to get a list of what did we build right the first time, which was actually very, very, they had never had before, which was great for them to have, to see again what, what leads to being able to build things right the first time. But first, you need the data about it. And then here an example of automating layout of mechanical and piping systems as another example, quick example of automation. So to allow you to rapidly iterate between different design options. So I should have probably come back to the comment, the automation of process changes everything. Because I think you saw that in the structural optimization method. If you can do the structural design in 1 hour instead of weeks, you can imagine a very different design process where you can have a very different interaction between the architect and the structural engineer and then the construction companies than is possible today. So that's what's really meant with this automation of process changes everything. And the same here with the automation of mechanical systems design. Okay, so I hope you found the examples illustrative, helpful, to make sure that it's clear what I mean by visualization, integrated information, and automation. Of course, we have to make many more types of decisions than I was able to show, and there's many more types of visualizations, integrated information, and automation than I was able to show. But hopefully this framework helps you increase the value you get from BIM on your projects and create better projects. So I'm happy. I don't know if you have time for a couple of questions or, yeah, as you like, Luis Gerardo.
Muchas gracias, Martín, por esta presentación tan interesante. Sí, hemos recibido algunas preguntas del público. Voy a leer algunas para que Martín pueda responderlas. Primero lo voy a hacer en español y después las voy a traducir para que Martín las pueda responder. ¿Qué tecnologías emergentes o tendencias se espera que revolucionen BIM o VIA en los próximos años? What emerging technologies or trends are expected to further revolutionize BIM or VIA in the coming years?
Yep. So if I did this presentation, one example, if I did this presentation in a few months, I think I could show some examples in one project, but we're in the middle of the project, so we're still doing the analysis and everything. But in that project, we are able to compare finding clashes with rules versus desktop-based review versus virtual reality review, and to see what kind of clashes you find. So we've seen that with virtual reality, you can find, at least today, that's what it looks like, more of the operational issues, like I also illustrated with the wastewater treatment plant. But then the challenge we found on doing that is that when we have to review in virtual reality, the comments are done in natural language and they don't really easily fit into sort of a clash management system. And but we're able to develop natural language, as you can imagine, natural language interface, so that we can create the structured information that's important for management of these clashes and improvement of the design. So this combination of virtual reality and large language models looks actually pretty promising to enable a fluid interaction of many disciplines on a project, and then but then also get the benefit of having data-driven, data-enabled management and analysis methods. So that's one example that comes to mind. And then I think it's pretty exciting. I don't know when quantum computing will be here, because yes, we could develop the structural optimization method, and for good sized building, we worked on buildings in downtown San Diego, so the kind of buildings you see in downtown San Diego, that's what we were able to optimize. But it's as impressive as that was, I would say. It's just a structural system. We have many other systems, right? The facade and the mechanical and piping and so on. And so optimizing all of those systems together would be pretty exciting to be able to do. But I think that would be difficult still to do with today's computational power. So So those are, I think the computational power will sort of revolutionize what we can do. In terms of generative AI, generative design, of course, there's quite many people working on it, and we have some little bit crazy projects in that area as well. But the challenge we have seen, and I don't know if you've seen that as well, is that um, that we don't have really enough data to compare, and we don't have enough data that are labeled that tell us this is good, this is bad. So I think right now it looks like that's maybe slightly more on the horizon. But those are a couple trends that I see that I'm pretty excited about.
Gracias, Martín.
Yeah.
La siguiente pregunta, bueno, estaba relacionada también con realidad virtual, pero bueno, ya Martín respondió esa pregunta. La siguiente, ¿cómo afecta la implementación de BIM dentro de BDC en comparación con su uso aislado en proyectos tradicionales? How can BIM, no, how does the integration of BIM within BDC influence project outcomes compared to traditional project workflows?
Yeah. I mean, most people, most companies start with bringing BIM to a traditional workflow, and you get, in my experience, some benefits, but they tend to be a little more isolated. But hopefully, then some people will notice there, and the main differences I've seen is you can develop your BIM much more rapidly because you have more people working on it and more fully. You end up with one way of working on a project instead of if you bring BIM in a traditional project, then you have traditional method and BIM, and you have two methods of getting information and using information, which is also a bit disruptive. So if you can really bring the whole project team behind it, you can avoid that. And then the benefits are basically more and earlier. And what we have seen is that it's the individual benefits go up and the collective benefits go up. Because often I hear, yeah, that's all very nice, but that's the contractor will benefit. What about me as the designer? And I just have the cost. But in our research, that is not the case. The designers benefit also. They just need to be able to see it. That's a challenge. So that's kind of what we see. Just the myth that I mean, I'm sure there's situations where probably somebody has a bit more cost and others have a bit more benefit, but we haven't seen that very much actually. So we've seen really the benefit being strong when you do more BIM uses, not just the whole project or particular parties benefit, everybody benefits. That's what we have seen.
Gracias, Martín. Hay otra pregunta. ¿Cuáles son las estrategias clave usadas para
So actually, I see that
manejar?
question, but I think they seem to get translated directly. So what are the key challenges, or where are we? Let's see are there some
Strategies used to achieve the cost saving without compromising structural safety?
sorry, maybe say again. What are the key
What-
strategies used to achieve discussing without? Yeah. So of course, in the example, there's no. I mean, you can imagine in California with the earthquakes, you cannot compromise structural safety. I mean, so the structural performance for the designer, the structural engineer, or the one we made was at least was equal, or the one with the optimized method was at least as good, if not slightly better even. So you don't have a choice there. Obviously, compromising structural safety is just not an option, obviously. And the main thing is really the alignment of the main structural elements, so that they lead to productive details. Because you usually have a range of choices there in terms of beam depth, flange, concrete depth, the amount of composite action you want to get, and so on. So there's usually a range of options, and depending on the particular situation, the particular fabricator, what works well for them, one or the other choices is more productive, more cheaper. So it's really from the alignment of the main structure with all the details. And not obviously compromising structural safety. And so that's where the sequential method we typically use today, doesn't get you that. So being able to do this concurrently is really key.
Gracias, Martín. Christian Hanco, in what ways does automation within workflows improve projects efficiency and reduce errors?
Well, in my experience, when you have automated something, then you have created a consistent process, which is basically impossible to, in my experience, also pretty much impossible to do when it's mostly human-led process. It's just the way it is. I don't mean, to complain about people, that's just the reality. And we should use the people what they're good for, and the tools what they're good for, and the tools are good for creating, consistent process. And so when we have automated something, we have made something really consistent, predictable, and then we can count on that. We can count on how long it takes. We can count on the result you get, which is difficult to do. So that's where I've seen really the main benefit mechanism of then becoming more efficient and effective.
Gracias, Martin. Juliana Nicho, have you noticed significant differences in decision making when teams use virtual reality models compared to just 3D models on a screen?
Yes. Yeah, for me, it's crazy how little we use that. In my experience, we should use virtual reality a lot more, because I've always seen fantastic benefits over just looking at 3D. I've not been in a signal situation where people said afterwards, "Oh, that was a waste to use the virtual reality. We didn't learn anything new." Being able to be together actually immersed in the environment somehow seems to unlock something in our brain that leads to much better insights. I mean, yeah, I could talk about many examples. I mean, one example comes to mind quickly was the design. A few years back, Disney was creating a very nice restaurant, and for that they wanted to attract a very good chef. So they wanted to create the perfect kitchen. They wanted to bring a more wider range of guests to the theme park. They wanted to offer more dining options, more food options, and one of them was a little bit nicer restaurant than typical. So this was quite key to the overall strategy of the company. And you might think, well, what the heck, kitchen design? But it was actually quite important, right? And they worked really, the design team, integrated design team, using 3D, looking at lots of options. Basically, they did all of that. And they said, we have the perfect kitchen. It's like absolutely perfect. And then somebody said, well, maybe we should invite the chef to actually go into the virtual reality model and pretend to cook. We should just see. No, we don't need to do that. We have designed the perfect kitchen. No, maybe, come on, we've taken this so far. Let's do this. So finally they said, okay, fine. But there was a lot of people skeptical, like, this is a waste of time, and let's just go on. And so then the chef went into the kitchen in virtual reality, pretended like I'm working here, I'm cooking. And they said, everybody else, the design team was watching. And they said within 5 minutes, it was clear that we had made a big mistake with the placement of the sink and the stove. Basically, the analogy is somebody said, it's like somebody put a telephone pole in the middle of your driveway in front of your garage. And nobody had seen it without that. So, I mean, every single time when a user, that's my experience, but every single time when a user of a facility actually goes to use it in the virtual reality, the feedback is amazing and super powerful and super important. So you can tell I'm a little bit passionate about this topic, because I think it's crazy that we design buildings and not have users give us this feedback through virtual reality experience.
Gracias, Martín. Ciertamente es necesario que las personas que operan o los usuarios finales tengan que ver todo y si se puede ver con la realidad virtual, ayuda al diseño, ¿no? Entonces, incorporar al usuario inicial en el diseño y al constructor también es algo importante. La siguiente pregunta, Raf, could automation be implemented in structural design optimization?
Yeah, I'm not sure. Could automation? I mean, you cannot. I don't see how you can do optimization, structural design optimization without automation. And for me, that's like, but it's also, I think, in my mind, one of the main purposes for automation. Because there's, again, right, whenever you have something that you have many, many possible design options, then I found automation is super important, but they also have some rules, like in structural design. Then automation is possible and also good to have, because then it allows you to play through different systems and different designs and see where the optimal designs are. Again, we've tried this on quite many types of projects. And again, we have not yet seen a case where we couldn't find a better structural design, even compared to amazing structural engineers. So I think for me, the lesson has clearly become, of course, it's great to have, in this case, a good structural engineer, but a good structural engineer with an automation tool is really amazing.
Gracias, Martin. Luis Miguel Merma. Good afternoon, Dr. Fischer. I have a question regarding the structural analysis in BIM. As we know, models often rely on assumptions about material properties and loads, but real-world conditions can significantly differ from these theoretical predictions. In your opinion, what advantages in real-time structural monitoring and adaptive modeling could help bridge this gap and improve the accuracy of performance assessments?
Yeah, two answers here. So one thing that was very helpful was, of course, by having the fabricator and director provide data together along with the structural engineer, took some of the assumptions away. But of course, then the underlying model still quite make many assumptions, I agree. And in that sense, we used, so if you trusted the structural analysis of the structural engineer, how they're working today, we used exactly the same tool. I mean, we used exactly the same tools because, yeah, we needed to, right? Otherwise, people wouldn't believe the analysis. But then you have a very good point in then verifying those models through monitoring, and I think we need to do more there. So that's probably another area that, yeah, would also be interesting to explore. Not only for structural performance, energy performance, we're working quite a bit in that area to, I'm sure many of you have probably also done automated energy simulation, optimizing energy performance, the design of buildings to improve energy performance, just like the example of structural engineering. But there, in our experience at least, the discrepancy between the predictions of the models and the actual performance is quite high, and we need to improve, how well the analysis models actually predict performance. And for that, you're absolutely right that monitoring, creating feedback loops is essential. And but for that, we also need, in my experience, data-driven methods, machine learning, etc., because it's way too much data to make sense of for a person. And we need to, deploy these data-driven methods. But that would be a really, I think, excellent topic for a presentation, or maybe it already will be in this conference. If not, then we should think about how to talk about that a bit more.
Thank you, Martin. And the last two questions. What aspect of BIM implementation still require further research, and how should the industry address them?
I think for me, the one that I just mentioned, creating these feedback loops. So that what we put in the BIM and then the performance that we calculate from it, how close to the actual reality is that? And I think that's once we can do that, then you could imagine, right, once we can trust those models more, then I think, yeah, then it will be, well, we'll see. I've been wrong before with these predictions, but then it'll become pretty inevitable that we use them, right? Today you can have these kind of excuses. So in my mind, that's really a key area, is creating these feedback loops. And yeah.
Thank you, Martin. And the last one, how does 3D visualization help identify problems early in a project?
Yeah, for that, I find you need a combination of people that are good in creating visualization and people who understand the possible issues, risks on a project. And then you can create the visualizations very rapidly that help you do that. So I don't know if some examples, quick examples would be helpful. For example, when we were working with Disney on Hong Kong Disneyland, the overall design of the park, a particular visualization was key, but that was, because one of the key project managers could foresee this risk. He said, okay, we are designing the theme park, which is, of course, we need to do is our job. But there's different strategies in how we are going to develop the utilities for the theme park. And we are like too focused internally. Of course, we have to do that. We have to, for example, there was one strategy was let's build a utility door across the whole site and then feed everything from there, or let's have a more distributed system. Different advocates for one or the other. But then he commented, well, we're building this theme park on a new island. And then there is, all the utilities have to be brought to this island by the city. We will take care of all of those utilities on the land of the theme park, but the city will bring the utilities here. And depending on how and when and where the city brings the utilities, one or the other strategies that we have works or doesn't work. So if we want the strategy we want to deploy, we need to communicate with the city in terms of when and where we need what utilities. Otherwise, this doesn't work. So we created quite quickly these visualizations that showed the different utility strategies, made them realize from the Disney side, which of these do they want. So, and then they had a visualization to go to the city, or and get alignment. And so usually important right. This could have been a huge problem on the project if you didn't recognize this early. Or on a hospital project in Phoenix, they had a particular construction strategy that required a crane in a particular location. And then somebody realized, wait a minute, what's happening with the helicopter that brings patients to the hospital? Because we need to get a flight path approved from the Federal Aviation Administration. And let's understand the relationship between the crane and this flight path. And then they realized again, a very simple visualization so that people could really understand it. And then once they saw, then they realized, oops, there's a conflict. Because they saw it early, they could apply for a different flight path from the FAA. If they had not recognized this early, the project would have stopped, right? Because you cannot have a hospital without a helicopter that can fly, and the helicopter needs an approved flight path that's workable from the FAA. So I mean, I have just many more examples, but basically for me it shows that the people with experience, they need to point out what are the risks, what could cause a major problem later, and then in my experience you often can create quite a simple visualization very early to confirm, yeah, this is actually an issue and or not, and to involve the different stakeholders to come up with a good solution.
Thank you, Martin. Martin, on behalf of the Olimpiabim 2025 and the organizing committee, we would like to express our sincerest gratitude for your participation in this session. Your presentation has been invaluable in enriching our understanding of BIM and its application in decision-making through visualization, integration, and automation. To show our appreciation, we would like to present you this certificate recognizing your contribution to the Olimpiabim 2025 conference. Thank you once again.
Thank you, Luis Gerardo, for hosting, and thank you, participants. Also, thank you for the many active questions. If somehow we happen to miss something or you have another question, please feel free to email me, and we can stay in contact that way. Have a good rest of the conference.
Thank you, Martin. Con esto damos por concluida la sesión de Olimpiabim 2025. Agradecemos a todos por su participación y compromiso. Esperamos que esta sesión les haya brindado conocimientos valiosos e inspiración para aplicar BIM de manera más efectiva en su trabajo. Esperemos verlos en las próximas sesiones y que puedan participar en el Olimpiabim que ya se viene en la siguiente semana. Que tengan un excelente día. Hasta pronto.